Hello, I'm Stefan Greber, project leader for LXD, and today I'm going to be talking about GPUs, specifically NVIDIA GPUs. I realize we already have a video on the channel about NVIDIA GPUs and LXD, and that was primarily focused around containers and virtual machines when using consumer-grade, commodity-type GPUs. This video is going to be a bit different because instead of looking at the consumer grade stuff, we're going to be looking at what's, I believe, currently still pretty much the top of the line of enterprise grade GPUs. So instead of looking at, I believe it was a GT 730 or like an extremely cheap, extremely slow consumer grade GPU in the previous video, this video is going to be using an NVIDIA A100. The particular model I've got here is one with 40 gigs of HBM2 memory. The most recent version of it, I believe, is an 80 gigs version of it with HBM2. That is not a cheap GPU. That's probably out of reach from most people, unless you're really into running very large scale machine learning, deep learning type workloads. That's probably not going to be the kind of GPU you're going to be using at home. But that's the kind of GPU you can sometimes get in the cloud, for example, for specific workloads. It's also kind of interesting to say that this really isn't really, I mean, this card really isn't a GPU. It doesn't have any graphical output, as is the case with most of NVIDIA's enterprise grade cards. Those usually don't have physical ports on them. But also, it doesn't really have all of the rendering frame buffers type feature or video encoding features that you would normally see on traditional GPUs. Those cards instead really allocate most of the die space to extremely fast memory, in this case 40 gigs of HBM2, and to specific features that are useful for things like machine learning, deep learning, specifically things like doing decoding of photos, as well as giving a lot of the extra die space to additional CUDA cores and processing units for AI type workloads. That's, to be fair, way out of what I'm usually familiar with. I don't really do any kind of deep learning, machine learning type thing. I'm mostly a hardware hypervisor and kind of Linux guy, so that's a bit different for me. But in this case, we're really going to be looking at the hardware and how that works with LXD, both with containers and virtual machines, and what you can do with that kind of hardware. So let's get started and move over to a test system I've got in my basement here. This machine, that's the one we use for, LSCPU. That's the machine that we're using for testing anything that uses PCIe Gen 4. So it's a AMD Ryzen 5 3600 on a top-of-the-line motherboard with a bunch of PCIe Gen 4 lanes. And it's got some reasonably fancy hardware. In this case, it does have what's just supported by Linux as a 3D controller. No details on the model or anything. But this machine also has a dual 100 gigabit networking, which we can see right after here. So that's that particular test system that we're using. Now on the NVIDIA front, I already have the drivers installed. All of this is on Ubuntu 20.04. I did try 22.04, but some of the drivers that we need to work with just don't quite work yet, apparently. So this one is running, as I said, an NVIDIA A100 PCI, and it's the model with 40 gigabyte of HBM2 memory. It's a reasonably power-heavy machine. Well, GPU, it can consume up to 250 watts. We can see that right now it's idling at 36 watt and it's cooled to 32C. The other thing that's worth mentioning with this particular GPU is that it is entirely passively cooled. It's designed, so it's still a PCI model of that particular GPU, but you need a chassis that's capable of actually pushing enough air to cool it down. This thing can get really, really toasty when fully loaded, so you need proper cooling for that. Anyway, that's effectively what we have as far as the hardware. Now, this GPU is interesting because it supports a lot of different features. So we'll start with things that work effectively with a consumer grade driver, and then move on to things that require the NVIDIA Grid vGPU offering, which includes actually you need licensing and comes with a bunch of extra cost. So if you were on the consumer grade driver, you could, just as it stands right now, either pass it in full to a container or a virtual machine. You're using normal pass-through, it will work just fine. Or you can use a feature that's called MIG, and you can see it here in the report shows MIG as being disabled. MIG stands for multi-instance GPU, and it allows for physical segmentation of the card. So there's like different kind of GPU units on the card that can have dedicated memory. That allows for multiple applications or containers in this case to have dedicated access to a subset of the entire GPU and have their own dedicated GPU time memory and not be able to impact anything else running on this particular GPU. So that's what we're going to be starting with. The first thing to do is actually enable MIG, and you do that with NVIDIA SMI-MIG1. So you run that. And then NVIDIA SMI is going to report that MIG is now enabled. And then you can take a look at the profile. So there's a MIG-list or LGIP for list GPU instance profiles, which then gets us the list of profiles that can be used. There's also an indication as to how many you might be able to run. So you could create one profile of 40 gig, but then you're literally going to get a single one of those, and that's it. That's the entire GPU is used right there. The secondary profile with 4 of the GPU units and 20 gig of RAM is still restricted to a single one of those, fortunately. So not super useful in our case. Or you can do three GPU units, 20 gigs of RAM, and those you could have 2 of those. Or there's a profile that gets you 3, or yet another profile that will get you 7 smaller chunks. So what we're going to be doing here is use the create GPU instance. I'm going to be asking for one instance of the 2G 10 gig. So it's this one, as well as one instance of the 1 gig, well, actually 2 instances of the 1 gig, 1 GPU 5 gig. So this one. What's interesting is that obviously those just use a bunch of resources. So if we list things again, we're going to see that now a bunch of those are set to 0. So there's no more availability whatsoever. We could still create 3 of the smallest one, or we could create 1 of the kind of mid-size one if we wanted. Once that's done, the next step is we can just list them. So listing GPU instances, we can see they're running with their IDs. And then that's the GPU side of things, but now we also need to tie that to a compute instance, which effectively decides whether you want to further segment and actually share some of the memory between multiple instances. And that's used by looking at another type of profile. So it's list compute instance profile, which gets us those particular profiles and how many we can get of each. And then what we're going to be doing is creating compute instances. So in this case, it says we're going to be creating an instance with 1 GPU, 5 gigs of RAM, and that's going to be using the GPU instance ID 7. So it's going to attach it to this thing. Okay. Then I'm going to do another identical one attached to GPU instance 13. So this guy. And then a slightly longer one, which is going to be creating 2 instances on top of the larger one, instance 5. All right, so that's all created. That's effectively the physical slicing of the card and then some amount of logical slicing. And the result you can look at inside of NVIDIA SMI. And what we see here is that's the bigger GPU instance, and we can see it is then further split in half as far as the compute instance. We see compute instance 0 and 1 in this one. So they will be sharing resources in this case. And then the other 2 are just have a single compute instance per GPU instance. So they're freely dedicated, and we can see the resources here. All right, so we've got that created. Now let's look at the LXD side of it. The first thing we'll do is just show the basic full pass-through of a GPU. So I'm going to be creating an instance using a 2004 image and setting the NVIDIA runtime to true. And then I'm gonna just adding a GPU called GPU1 to that instance that's called foo, and set the GPU type. Actually, it's supposed to be physical, I think. Physical, and then the PCI address of what we want to pass. There we go. And then we can start that. And if we go inside of that instance and then run NVIDIA SMI, we can see that it doesn't actually see any of the MIGs that we created because it's got past the entire GPU, but it does have access to the full GPU itself and could run whatever it wants on that. So that's what you can do on any normal card already. There's nothing particularly special about that particular piece. Where things get more interesting is when we start actually using the multi-instance GPU feature inside of LXD. So I'm going to be creating another one that's called bar, exact same image, but this time I'm going to be adding the GPU, which requires a bit more work. So I need to list the UUIDs. This can be done here. Those are obviously going to be unique, so they're going to be changing every time you create something different on the GPU, and you can do device add and to bar GPU 0. It's a GPU. The GPU type is MIG, and then the MIG UUID is whichever one you want to pass. So say we want to pass one of the instances on top of the 10 gig slice. So let's do that one. And then just need the PCI ID of the card so LXD can locate it. And then start bar. Now if I go inside of bar and then I run NVIDIA SMI, here we can see that it has access to that 1 MIG. Then if you stop it, you can do it again, this time doing GPU 1. I'm gonna be changing the UUID to, let's say, one of the small ones, and then start bar again. And now it has access to 2 of the MIGs, one of the slices from the big one and one of the smaller ones. And that's pretty much what there is, like how MIG works. It lets you do physical slicing of the card and then create those compute instances, and then you can use them inside of containers. You can, in this case, I've assigned 2 to that container. I could create multiple containers and assign different slices. Just like normal LXD GPU pass-through to containers, there's nothing that prevents you from using the exact same slice in multiple containers. That will work just fine, but then you might end up with resource contention and conflicts between the applications you're running. All right. So let's clean things up. I'm going to be deleting all my instances here, and now switch to the even slightly weirder thing that we can do with this particular card. So I'm disabling the MIG feature on the card. Can confirm that there's nothing left right now, so the card is effectively back to its normal state that you would get after a normal boot of the system. We can also see that we warmed it up a tiny bit by running it through those instances and just creating instances, well, GPU instances and everything on it. But now what I'm gonna be doing is something that would actually require a different driver normally. In this case, I'm actually doing the entire demo on the NVIDIA Grid driver, which is a driver you only get when you are a paid customer of NVIDIA, when you're fully licensed for that particular card. When you're using their vGPU Grid feature, you actually need to run a licensed server so that all of your guests can get a valid license to run. So that's another kind of thing to keep in mind is not only is the card reasonably pricey, but if you're using more than just MIG or the raw card, as I showed so far, if you want to actually slice it and then pass that to virtual machines using NVIDIA Grid and NVIDIA vGPU, you're going to have to get a different driver. You're going to need to get licenses to do this. That being said, let's go play with that feature. So another thing that's interesting with the A100, I think that's where it debuted, is NVIDIA now supports SR-IOV. It's not really working the same way you would expect SR-IOV to work on something like networking, where you get a fully dedicated VF that you can pass as it is directly inside a guest. As far as I can tell, NVIDIA is using SR-IOV more as an additional security feature to get the IOMMU feature to actually better handle the memory security. In any case, on this GPU, you can turn that on by running the SR-IOV manage and then -E and either a single card, or in this case, all the cards, because I only have one of them. That's easiest. Once you've done that, if you look at LSPCI again, you can see that the card did in fact turn on a bunch of virtual functions. So they all showed up here. So SR-IOV is now enabled. You need your system to have IOMMU and related options enabled in your firmware and in your OS for that to work. Now that I've done this, let's look at how that looks like in LXD. So LXD has a resources API that can be used to list GPUs, and especially list, in this case, both the SR-IOV layout and the mediated devices that are exposed on top of those virtual functions. So if we scroll down to the GPU section, we're gonna see here, that's the NVIDIA A100 40 gig. So that's properly detected. We've got the CUDA version, all of the versions from the NVIDIA driver are all detected here. Then it detects that there is a maximum of 16 virtual functions. They're all currently enabled. And then it proceeds to list every one of the functions. And then you see, so this is effectively your first function here. And we can see that it comes with a number of MDEV profiles. So those are the mediated devices profiles that we're going to be using for virtual machines. And we can see the maximum number of instances that can use any given profile. So again, if you use one of the very beefy profiles that comes like with a 40 gig amount of RAM, then you're only going to get a single VM out of this system. But you can, if you use the one that just comes with 4 gigs of RAM, then you can run 10 of them. And presumably if you're using the 80 gig model of the A100, then everything is doubled. All right, and as I said, like it enabled 16 VF, so we're gonna be seeing this 16 times. It's the exact same output. The reason why it's showed 16 times is just because of that extra level of isolation that comes from SR-IOV. Now on the LXD side, what you're gonna be doing here is just create a virtual machine. So this is an Ubuntu 2004 virtual machine called Foo. It's got 4 vCPUs, 8 gigs of RAM, and I'm disabling secure boot. That's required because the driver I'm going to be installing inside of that guest would normally require some extra steps to work with secure boot, and I just took the easy road in this case. Now what I'm going to be doing is use an NVIDIA 471 profile. So if we go down again in the list, you can see that NVIDIA 471 is this guy, and NVIDIA 471 is 10 gigs of memory. And I can run a maximum of 4 instances using that. So using that particular profile looks like this. So again, we're doing an add to instance called foo, which is now a virtual machine, not a container anymore. It's GPU1 and type is GPU. GPU type is now MDEV. The MDEV profile is NVIDIA 471 and the PCI address hasn't changed, still the same one. Okay, and then start the instance. And just to show that this works with multiple instances, we're going to be immediately creating a second one called bar, same command effectively, and another identical instance of the GPU, and then starting bar. Now, if we go inside of Foo, which we would have booted up by now, there we go, gonna need to install a driver. Those drivers, just like the one I'm running on the host, you only get if you are a NVIDIA customer and got access to their portal. You're gonna see me download the driver from a local server. Don't even try downloading that yourself from there. It's just internal only. That's what we use so that we can run those tests automatically in our labs. But that address is only accessible from here. First, I need to install some build dependencies so I can actually build the kernel driver. Then I'm downloading that deb that you would normally receive from NVIDIA when you're one of their customers. Then I proceed to install the driver, which will unpack all the usual binary bits, including libraries, CUDA, NVIDIA SMI, all of those things. And we'll also build the driver for this particular kernel, which is, again, an Ubuntu 2004 system with a stock 5.4 kernel in this case. All right, so that's unpacking and now building the driver. That should take a few seconds. That's actually the main reason why I give more CPU and RAM to that VM, was just to try and speed that process up, because the first time I ran it with the stock config from LXD of 1 CPU, 1 gig of RAM, it took a few minutes to build, which was a bit longer than I would like in a demo. So hopefully this time will be a bit faster with the additional resources. Okay, so that's built and should have loaded. So now if I run NVIDIA SMI in there, there we go. So we can see that it actually does mention grid. So that's the indication that you're dealing with a slice of a physical CPU. You can see it's in the 100-10C. Presumably the 10 refers to the amount of RAM, I'm good guess, which would match the 10 gig we're getting. And if you look at the PCI output, we can see here that same thing. We've got a 3D controller of NVIDIA Corporation without any more specific details. But you effectively have a working NVIDIA GPU inside of your virtual machine. And if we go look at bar, I can't show NVIDIA SMI because it doesn't have the driver installed, but we can check that the PCI output, if I install PCI utils, will also show that it has a similar NVIDIA GPU attached to it. And based on that profile, I'm trying to remember if it was 8 or 4 of them that we can run. Let me see, it was the 471 profile. I believe it's 4 because it's 10 gigs of RAM. So yeah, I could run another 2 and we'd be fine. Now on the host, if you run NVIDIA SMI, what you're gonna see is that you've got 2 virtual machines that are running. So you can see the vGPU process that's run to manage that. I guess if I look at the process here, yeah, we see the vGPU process, and you can see that it's effectively reserving the 10 gigs of RAM for each of those. Then can clean things up, deleting the 2, and I can do the SR-IOV manage and disable it, at which point the card is effectively once again back to stock with nothing running and no MIG enabled, no vGPU enabled. So that's it. That's really your look at how things behave when you're dealing with the enterprise grade GPUs from NVIDIA. So both the multi-instance GPU feature as well as the VDEV grid type feature. Again, the multi-instance GPU is only available on very few GPUs from NVIDIA, but if you have one of those, then you don't actually need the grid driver for that to work. You can use the normal driver, it will work just fine. You need the grid driver if you want access to NVIDIA vGPU and like all of that VM management and resource allocation there. You need the paid driver for that, and you're gonna need the licensing server and licenses and all that stuff to be put in place. I hope this was useful to some of you. If anything, to kind of see at how the data center grade hardware behaves and just how easy it is to actually make use of it from LXD. Like there's really not much complexity. You effectively gonna have usually a table on the side of all of those profiles and like how big they are and how much like what kind of resources you can get out of them. You pick whatever is best for your instance and you go with that. And LXD will just create whatever needs to be created and pass it to either your container or virtual machine, depending on what it is you're doing. So again, hope that this was useful to you. If you've got any questions about it, feel free to leave them down below in the comment section or on our community forum. And I'll see you in the next video. Bye.